Every tap on your phone, every swipe, every photo, and every app you open is powered by one component, the mobile processor, also called the system on a chip. In this video, we are going to explain every major mobile processor concept, what mobile processors are, how they evolved, why some are faster, why some are more efficient, and why brand names do not tell the whole story. By the end, you will understand mobile processors better than most smartphone users ever will. Let's start with the basics. A mobile processor is not just a CPU. It is an entire computer on a single chip. Inside one tiny piece of silicon are multiple components working together. The CPU, the GPU, the AI engine, the image signal processor, the modem, the memory controller. This is why it is called a system on a chip. Unlike desktop computers, mobile devices need everything integrated. Because power, space, and heat are extremely limited, early mobile phones had very simple processors. They were designed only for calls and messages. No multitasking, no apps, no graphics acceleration. As smartphones emerged, processors had to evolve rapidly. The first smartphones used single-core processors. They were slow by today's standards, but revolutionary at the time. Then came multi-core processors. Instead of one core doing everything, tasks were split across multiple cores. This improved performance and allowed real multitasking. But raw speed was not enough. Battery life mattered more than anything. This led to a key concept in mobile processors: efficiency. Mobile processors are designed to do more work, using less power. This is why mobile CPUs are very different from desktop CPUs. They use simpler cores, running at lower clock speeds, but in greater numbers. Now let's talk about CPU architectures. Most mobile processors use ARM architecture. ARM is designed for efficiency. Instead of brute force power, ARM focuses on smart instruction design. This allows phones to run all day on small batteries. Within ARM processors, there are different types of cores. Some cores are powerful. Some cores are efficient. This is called big and little design. Powerful cores handle demanding tasks, like gaming and video editing. Efficient cores handle background tasks, like notifications and music playback. The processor switches between them automatically. You never notice this happening, but it saves enormous amounts of battery. Now let's talk about major mobile processor families. Apple designs its own mobile processors. Apple chips are known for strong performance and excellent efficiency. Apple tightly controls hardware and software. This allows deep optimization. Apple processors use custom CPU cores instead of standard ARM designs. This gives them a performance advantage. Apple chips also include powerful GPUs and advanced AI engines. This is why iPhones feel fast, even with smaller batteries. Next is Qualcomm Snapdragon. Snapdragon processors power most Android phones. They are used by many manufacturers. Snapdragon chips balance performance, efficiency, and connectivity. They often lead in modem technology. This gives them strong cellular performance. Snapdragon processors also include powerful GPUs, used for gaming and graphics. Then there is MediaTek. MediaTek processors were once considered budget chips, but that has changed. Modern MediaTek processors compete at high performance levels. They focus on efficiency and value. MediaTek chips power many mid-range and flagship devices today. Samsung designs its own processors called Exynos. Exynos chips are used in some Samsung phones. They integrate well with Samsung hardware. But performance has varied across generations. Some Exynos chips struggled with efficiency. Others performed very well. Samsung continues refining its designs. Now let's talk about Google's processors. Google introduced custom processors to better integrate AI features. These chips focus heavily on machine learning, camera processing, voice recognition, on-device intelligence. Raw performance is not always the highest, but user experience is optimized. Now let's talk about GPUs in mobile processors. The GPU handles graphics, games, animations, video rendering. Mobile GPUs are extremely important. They determine gaming performance and display smoothness. Some processors use integrated GPUs, designed by ARM. Others use custom designs. GPU efficiency matters as much as power, because graphics workloads drain batteries quickly. Now let's talk about AI engines. Modern mobile processors include neural processing units. These accelerate AI tasks, face recognition, photo enhancement, voice assistance. AI engines allow processing to happen on the device. This improves privacy and reduces cloud dependency. Now let's talk about image signal processors. This is one of the most important components. For camera quality, the image signal processor handles raw sensor data, noise reduction, color correction, HDR processing. A good camera is not just about megapixels. It is about processor image capabilities. This is why two phones, with the same camera sensor, can produce very different results. Now let's talk about modems. The modem connects your phone to mobile networks. 4G, 5G. Some processors have integrated modems. Others use separate chips. Integrated modems are more efficient. They save power and reduce heat. Network performance depends heavily on modem quality. Now let's talk about manufacturing process. This refers to how small the transistors are. Smaller transistors mean better efficiency and higher performance. As process sizes shrink, chips become more powerful without using more energy. This is one of the main drivers of progress. But smaller does not always mean better. Design matters just as much. Now let's address common myths. More cores do not automatically mean faster performance. Higher clock speed does not always mean better efficiency. Benchmark scores do not tell the full story. Real-world performance depends on optimization. Thermal management matters. A processor that overheats will slow itself down. This is called thermal throttling. Good phones manage heat effectively. Bad designs waste potential. Now let's talk about performance tiers. Entry-level processors handle basic tasks. Mid-range processors balance performance and cost. Flagship processors deliver maximum power. But most users never need flagship performance. Everyday tasks require efficiency, not speed. Now let's talk about gaming. Mobile gaming pushes processors hard. High refresh rates, advanced graphics, processors with strong GPUs, and good cooling perform best. Gaming phones often use aggressive tuning. This improves performance, but reduces battery life. Now let's talk about longevity. Processor support determines how long a phone lasts. Software updates rely on chipset support. This affects security and features. A powerful processor with poor support ages badly. A well-supported processor lasts years. Now let's look at the future. Mobile processors are becoming more intelligent. AI will play a bigger role. On-device processing will increase. Efficiency will matter more than raw power. Mobile processors may soon rival laptops. For everyday tasks, the line between mobile and desktop computing is fading. In the end, a mobile processor defines your phone experience. Speed, battery life, camera quality, gaming performance, all of it depends on the chip inside. Once you understand mobile processors, you stop judging phones by brand names. You start judging them by design. And that knowledge changes how you choose your next device.